Hi guys. All right. So welcome to the OSI TCP IP model. This is our labs for the application that we have built that's going to be able to filter out our location and give us the content that is due us based on the location that we are coming from. So in a nutshell, what I'm trying to say is that we're going to look at how an application that we've built here and how it's able to do something similar in the real world. So something similar to, let's check that of these websites, Netflix, Oracle, and Amazon. So we want to do something similar to this Amazon platform. Example is Amazon platform. We want to be able to tell the end user or the user that we know your location, and based on this location, there are some items that we ship to Ghana. So you're actually coming from Ghana. If you haven't yet watched the part one of this video, I will advise that you take your time and watch the part one because that one helps you to understand how even they are able to know that you are coming from Ghana based on we talked about submarine cables that are laid and that of the regional internet registries that exist for every continent and how internet service providers um, liaise with these RIs and the whole organization that comes into this internet allocation from ICANN, and RIs and telcos or the internet service provider. So that's all in the part one, just a general overview so you know that every IP address that is connected to the every host that is connected to the internet, an IP that is being assigned. That IP that is being assigned, there are details attached to the IP that has been assigned because of the distribution of the internet from submarine cables and into the authorities of the RIs. Then later on, in quote, you decommission them to the internet service providers or the telcos that want to go ahead and share data or give end users access to internet or give them some form of data to also connect to computers or speak to computers on the global platform. So we've looked at all that in part one. So that we are just trying to build something like this. We have built it and we are going to deploy it onto Heroku and test and see if it's really working or it's not working. Yep, so this is Netflix Ghana. It's able to know my location, and another one too is Oracle. Yeah, just want to say is visit Oracle Ghana. All right, so that's about it. So let's go ahead and go to our ID. ID. So we have this gateway. This is the gateway. So once you come to the gateway, when you come to the gateway, it will tell you if you can have access to or you can um, connect to the resources in a particular service. So we have luxury cars microservices, mainstream cars microservices, microcast microservices, and sports cars microservices. So each service um, is a world, and in each of those worlds, you can perform actions in those worlds, or you can have some operations in those worlds. And all those operations, or that access or that privilege to do that will be based on your location. So if due to business arrangement, it has been said that we get it, but in this particular country, unfortunately, that resource is not yet available. Just as you saw on the platforms that we looked at, all those platforms, they were able to determine, once they determine your location for you, they also have their own um, business or use case attached to them. So the business or use case for each of the platforms we visited, they are all different. The business case for that of Amazon is in regards to shipment and items. So you can ship items in the US or items from different continents, but not all the items that probably are on their platform can be shipped to Ghana. So that's why they said we are showing you items that we ship to Ghana. So that's their use case of using the location content or the location of the end user to simplify or build a use case with regards to supply chain or its ship or delivery. That of Netflix also is also a different use case. So with Netflix, their use case of business arrangement will be we will give you access to probably services or movies that are recognized or you can watch from your location. And it could also be in they could also have this um, Netflix Ghana site also to support that of the Oracle's business case. Oracle's business case is more of making your resources available. So they have a data center probably that is in Africa that you can speak to instead of coming all the way to the US data center. That could be the same case for the Netflix Ghana. But the Netflix Ghana too can also have support for um, content that are coming from the region. So instead of you maybe striving to, let's say, enter into the American market, probably they, I don't know the, I'm not Netflix, but I'm giving an example. That probably it could be that okay, fine, we get it, but you have this site is mostly for Ghana content, or it could also be in a business use case of whereby they bring their content star in the US also closer to you. So once you are from Ghana, you can access any content from anywhere. But if that content is not yet available in that country, they can tell you that it's not yet available. I think there's movies have a way of releasing or deploying films that they make. Sometimes will be available only in the US, but the site you are visiting is the same netflix.com, but that movie is not yet available in your country. So when it becomes available, then you can now access it. So they don't want everybody coming to the US server, and when they all come to the US server, it says you cannot access. No, it's been released in the US for a reason. Then later on, it comes to other countries or regions. So when you route here, you go straight to the Netflix Ghana service or data center. Uh, that will give you your information. But that movie may not yet be released into that data center. And all this happening at the back end. That was just by the way. So let's look at our the same use case that we are building. But ours is regards to can you proceed or you cannot proceed. So we'll actually go ahead and deploy the application to Heroku. So I'll go to the Heroku profile. And this is my Heroku profile. So the application has several profiles. So if I'm going to deploy it onto a different environment, I'll create a profile for that. So when it goes to that environment, that profile will be active. So this is my Heroku profile configurations. So I'll actually change this description text here and I'll say I was um, I am deployed in Heroku. Maybe I'm deployed in Heroku. Let's just say Um, hello world from Roku platform or environment. So Roku is just a cloud application platform. In other words, is when you have applications that you want end users to access from the internet. Instead of delivering it on your local host, you can host it on Heroku or deploy it on Heroku. And that's the work of some VMs, virtual machines that are running behind scene. We won't look at all those into that today as to how you're able to deploy applications uh, to a site somewhere. What is the engineering behind it? And virtual machines come into play here. But I'm not going to look into that for now. We'll do that in another code film. Right, so we've changed our text and say hello world from Heroku. So let's go ahead and just deploy the gateway first. Then later on, we'll start the microservices for each of the entities that we are looking at or the cars we are looking at. So let's go ahead and say git add clear. Sorry, I want to take the text add and say git commit and say update or just say deploy to Heroku or deploying to Heroku or deploy to Heroku. So we do git push Heroku master. Right, so the engineering behind or the software um, intuition behind the Heroku platform is also that of your Git, similar to your GitHub repo, whereby you have your own account on GitHub. Every repo has an application. Every repo is an application. So in the same way, Git and Heroku has a platform, has an account. I'm just giving you the general engineering overview. They have an account, then with that account, they are every repository that you are deploying to, every repository that, or every application that you build is going to be treated like a repository. So based on that, you're able to do your deployment onto uh, Git. So it's a Git Heroku mechanism. But at the end of the day, the running is based on the activity of virtual machines. We'll look at all that later on. I'm not going to talk too much about that, but later on we'll create a code film on that. But it's not difficult at all. It's not difficult. It's the same engineering principles. Yeah, so we've done that, and let's just go ahead and test this. So you go and let's launch it. I didn't copy it well. All right, so this is our application. So this is welcome to API Cars Gateway. So this application is a cars gateway. So any cars you want to buy, probably you want to buy from Africa. I've made this welcome to the Africa API Cars Gateway. If that's not your use case, then you could have said that okay, we are not okay with that. We can rather do something else. So example maybe a payment gateway. Because if you want to make any form of payments to Africa, digitally. Probably as it stands now, there are no gateways. It could be, but I know there are some like Paystack and Flutterwave. But if they were not, it would be very difficult for us to be inconvenient for you to send money to Africa. Will you put it in a plane? Will you put it in a letter, an envelope? With how would you send the money? So with the help of payment gateways, you just take your phone and you send money from your account to um, your loved ones. Uh, could be their account or it could be even their mobile device, which is serving as their terminal. So that's just one way. Okay, so this is a cars gateway. So our application is going to do something similar to Netflix, something similar to Oracle, or something similar to Amazon. It's going to look at our location. Based on our location, it's going to tell us if we can enter into the world of luxury cars, mainstream cars, sports cars, or micro cars. And when we proceed and we want to do perform any operation in those worlds, we go ahead. But if we do not have, if we have imposed sanctions or restrictions on those worlds for those particular countries, you can't have access to it. And it's the same concept with regards to OSI TCP IP model, the framework attached to it, and how we are sending traffic to and through uh, a network to hosts based on the TCP IP model, whereby every datagram that is being assembled to be sent over the world wide web. There are protocols in place, and every layer has some form of uh, additional header or data that to add. So that's the whole understanding. It's based on this. It's all based on that. And we've looked at that in the part one. All right, so let's go ahead and also start the other microservices. These microservices will be running on localhost. And the reason is that I haven't the resource to be able to get more space for the cloud platform. I don't have it. That's due to one or two reasons, financial reasons. So what I'm going to do that I'm going to run these applications on localhost, but I'll create a gateway, and that gateway I'll expose the gateway to the internet, and with the help of that, any request that is coming to the gateway, it hits the localhost microservices. So it's just the same API cast gateway that I'm coming to touch. But when I touch this, I'll now if I touch this, I get my API gateway. But if I want to proceed to the worlds, I'll be hitting a local host gateway, but it has been exposed with a public URL and it's doing a reverse proxy to the individual small services. So that's the idea or the engineering idea. So all this will be aggregated into one gateway on localhost, but they will all have one public URL. And that's because I'm only exposing the localhost uh, port that they are all on for that particular AP gateway or that server. So we will look at that, and that's the idea of nudges. We're using nudges server to help us with that reverse proxy and gateway, um, the gateway idea that we want to implement. So we're using nudges server for that. All right, so with that understood, let's start the individual microservices for uh, cars gateway. So we'll start with Spring Luxury Cars. I'll run as Spring Boot app. I'll also run this one too as well. I'll run this one too as well. Okay, so let's go ahead and check um, our active IP connections. We've actually started our microservices, but let's just use some of the network command line tools to see all the just to check all the active IP connections we have on this host. We'll do 80. Right, so with 80, there are lots of 80. So we have 80. Search for, then it's searching for all 80 as possible. Let's now they're searching. Let's make it out of a port. Yeah, so when we do that, we have you can see 8085, 8086, 8087, 8088. Those are the ports for our microservices. So our services are they've actually started and we are good to go. If not, you could just check from here, but just a little bit appreciate why we use all these network command tools. Yeah, so they are all started. So what we'll do now is that we'll start our Nugget server. So we'll go to another terminal. Create a duplicate. Then let's start Nugget with command prompt because that's what I'm very familiar with. I don't use a Windows PowerShell. So we'll go to the CD then. Nugget, then just say start Nugget. So you know that Nugget has started. So how do we know? Just do tax list. And then in that tax list, we'll find the string nudges. Yeah, so since you have more than one instance that's running, because we already have some instances that we're running, we can actually let's kill everything. So as I'm forced to it because we are not administrative, we have no administrative rights. And let's list it again, then let's do 80. We should be able to send this as an array. So it seems one is the one more. Seems all have been killed. So 1.2004. So 2004. 2004. So great, we have done this instance running. So now let's go ahead and start our Nugget server, which is also going to serve as our localhost API gateway or the localhost reverse proxy directory service. In other words, when the request is coming from the internet, it touches our main gateway. For the individual worlds we want to enter, we have this public URL that will communicate to the microservices on their various ports through the reverse proxy server. Right. Right. So we haven't yet started. So let's start like this. Right. And let's confirm the. So we have Najis which has been started. So that's okay. Started. All right. Then let's go ahead and test. To test, we can go to the browser and just hit localhost 80. That's Najis server on that port. So port 80. So it says welcome to Najis. So the Najis web server is successfully installed and working. Further configurations required. And it goes on and on. So this is fine. So it's now left with how we set up the how are we going to set up this server gateway to be able to uh, catalog or accommodate or have makes room available for other applications that are running. So in other words, how are we going to aggregate those microservices into the Nugget server? So that has already been done. We'll just check it out in the property file. Yeah. So let's just go to where Nugget is. Let's use the terminal. Sometimes it's good to be a little bit geeky, especially if you're in a Linux environment or whatever. You will have to definitely use commands. Even though sometimes you can put a terminal on it. But let's continue. Then let's look at the Nginx file. So I don't have VI for um Nginx. So let's say Explorer. Can launch Explorer here, I'll be happy. Yeah, so I'll just go, I'll copy this and I'll go there rather. It seems I don't want to go moving between the directories and the terminals, as I have to go to I have to maybe start with Notepad. I don't want to do that, so I'll just use Notepad plus plus. So I'll just open it here. Okay, open Notepad plus plus. So yeah, so in this property file, this is a server. So this is the Nginx configuration, the server configuration file. So this is how we are going to, in other words, aggregate or accommodate other applications in this server. So we have our server, it listens on port 80, and the server name is localhost. So you can have now several Nginx instances based on your use case. And then for our particular use case, we created a proxy for the luxury car microservices, and this is the location for it. And then when you want to do that, it's going to hit at port 8085. That's for luxury cars. We have that for sports cars, micro cars. We have that for mainstream cars. So we've actually laid it up and it's very straightforward. So as and when the requests are coming through the localhost gateway to these respective microservices, we'll be logging them with the log format that we've set over here. So you know that it's actually hitting the gateway and doing the reverse proxy to the individual microservices. All right. So once we know that what we'll do is that we are now going to give not just a public URL. So the public URL for not just will use a different um, server to do that. So we'll build it on piggy.i. Alright, so Piggy will help us to get that reverse proxy we want, the public URL we want. So we'll do Piggy again. We need that. Help me out. So with Piggy, we are going to go ahead and get a public URL. So public URLs for localhost. So we just go click on this port 80 and we'll copy this command. And this will give us our public URLs. So all this, what that we're trying to do is that we're trying to expose the localhost to the world. So once we have that, let's go to our terminal. Let's paste the command over there. Okay, let's hit enter. Let's give it a random password. Alright, so let's test it and see. It gives you two URLs, one with HTTP, one with HTTPS. Let's go ahead and test this and see if when we test it on localhost, this is what we get. Now let's test it with a public URL, which in other words is it has been mapped to the localhost server or the localhost server and port. That any request that comes, it's like the domain name resolution to it to resolve to that. So let's confirm. Let's enter site. Let's see if it's working. So it seems there's an issue. It's not the tunnel is not working. So you can actually check on here. And it seems there's no response coming from the server. Alright, so what we'll do is that let's configure it this way. I'll copy this rather and I'll run it. I'll say I'll make it localhost rather. I'll make it sorry the localhost IP address. Sorry. I'll say 127. Because that's what has worked for me before. Right. Right. So let's test this now. Let's have our view that we had. So this for localhost. Let's go to video. Enter site. Right. So this is working. So when we use the IP address, it works. That's fantastic. So we're working now. So with this, we'll just go ahead and replace all the localhost instance or any URLs we are using for that service. So we'll go to application property file. So this is for Heroku platform. So Heroku will be able to speak to the public URL we've had. So we'll do the replacement here. So we'll say luxury cars will run on this port, run on this public URL. Same here, same here, and then same here. Okay. So we've actually set it up. And I'm running to an HTTP because I want to look at something. I'll explain that. So I'm fine now. And then one thing to I'll do is that I want to make all the applications um, available to all continents or all countries. Let's choose only Ghana because that's where we're coming from. So when we go to application properties, we actually have how we can configure the gateway boundary. Either it's a country based or it's path based. If it's path based, which means that if you are coming, if it's niche, if it's countrywide, which means that as long as you're coming from the country, you can't access anything on the gateway based on the status. You can access or you can't access. If it's path based, if you're coming from that country, you can't access those particular path based on the business or use case. So right now it is country. It is country. If it's country based, I'll just go search for Ghana. Yeah. Then I'll say allowed. So it's right now it's allowed for all countries, which is perfect. That's fine. And I like the status because that's okay. Later on we'll play with them, don't worry. We'll play with them. So that's fine. So now let's just go ahead and deploy. Git add, git commit. and see public URL for that's for microservice localhost instances. Maybe git push master. All right. So basically, what we are doing is that we have our application, we have our gateway. Then once the gateway is up and the microservices are up and they are running in localhost with our public URL, we just want to confirm that this application itself can sense and aside sense filter out the particular content or resource that has to be given to that country based on the IP that will be sent to the server. And once the IP is sent, you can go ahead and do that work. And we've explained all this already in regards to OSI model and then RIs. That's regional internet registries. So fine, now let's take our public URL. Then let's go here. So this is our implementation. So did you copy the right thing? Let's copy it again. Let's paste it here. Let's remove this and run to in there. Let's close all this. Let's focus on this for now. So that's good. So the status says allowed, which means that if you hit proceed, you should see the library cars catalog. Let's go to enter sites. Don't worry, you can get rid of this. So that's fantastic. So right now, because I'm coming from Ghana, it's been able to allow me, and we saw that already. So if we go to other roles to mainstream, we are now testing it to be sure that once you're coming from Ghana, you can access the particular microservices you want. So you can see we're having access. Once you go to sports cars to I see that we're having access to as well. And we come to the microcast too. We also have access. So now what we do is that now let's block all for the country. And once we block that, we now appreciate that it's actually checking our IP address there. We'll now elaborate as to, or we'll now dig deeper and we'll see how we can actually make this more practical in terms of visualizing it or what's taking place under the hood with regards to the TCP IP model. Yep. So it says block now. So we've changed the status, which means that we shouldn't have access like the way we are accessing. We shouldn't be able to route to these microservices or these worlds once we send this new updates we've done to the application or to our gateway. So if that's the case, let's now click it add. Let's commit. And say block MS services. Let's bring the microservices access from Ghana market. From the Ghana market or from the Ghanaian market. So in other words, anybody coming from Ghana can view this. Right, so let's go ahead and test this now. So to test it, let's push it first. So if you push it and you're coming from Ghana, and because I'm connected to an internet service provider, and then that internet service provider knows it's Ghana, it has registered as a Ghanaian company, and is being governed by the laws of this country. If I hit if the gateway again, it shouldn't allow me to access those words because I've said in my application configuration that once it's Ghana, block it. No one from Ghana should be able to have access to these microservices or services for any operation they want to perform. So our build is successful. Let's copy our URL. Let's go. Let's paste it again. You understand everything. I don't want to refresh. So this is now. So now let's test and see. If we go to large cast now, it says blocked, which is fantastic. Sorry. It says 406. It says sorry, but the service large cast one is currently blocked in your country, Ghana, which is good news. If we go to mainstream too as well, same response, same message, same issue, same message, same response, same issue. And then microcast too as well. Same response, same message, same issue. Which is good, which means that our application is working. It can actually know, it knows if you are coming from Ghana or not. So this is the country-wide blocking we've done. Now let's just do it path-wide. So to do it path-wide too, we'll go to path boundary. Even before we go to path boundary, let's let the application properties say, let's initialize the boundary type to path. And we'll go to our path boundary configurations. Let's go to Ghana. And in Ghana, as for per this configuration, luxury cars, world sports cars, luxury cars is available to the Ghanaian market, but sports cars is unavailable. So we've just made one change, and that change we've made is making it part wide. So if this is really enforced, what that means is that if we try to go to luxury cars world, it should be available. We should be able to enter, but when we're trying to go to sports cars world, we shouldn't be because it's unavailable. So we can go ahead and even test with these default settings. So what we'll do is that we'll just git, we'll make the necessary git changes. So now it's now path based. So we'll just go ahead and say git add, git commit, and we'll say set gateway boundary type to path. Then we'll push it. So it's unable to push. And give. I'm still connected to the internet. I have internet, so why is it? Give me an issue now. Is unable to access this. SSL no exclusive matches target whose no gets recover. Right, so let me do this. Let me just disconnect from the internet first. I'm connect again. Because we have been doing this just a few seconds ago, so there's an issue. Okay, so let's test it again. Yeah, so it's working now. So I'm sure it was the internet. Yeah. So it's sending our application to the cloud platform. All right, so it's done deploying. So let's go and test it and see. Let's copy the right way. Let's refresh this. Let's paste it again. Let's hit refresh. And we said that path base, if you go to luxury cars and you're from Ghana, per path base configuration, sorry, per path base configuration is supposed, if it's luxury cars for, it's supposed to be available. If it's sports cars, it's unavailable. So let's go ahead and test them. This luxury cars, available or unavailable? Available. You can see it, so you can go ahead and check the models. mainstream cars available because even if it's not set in a configuration file, by default it's available. Sports cars unavailable because you set it, but we hadn't set mainstream, but because we hadn't set it by default, it's available. Sports cards unavailable. Good. So it says unavailable. Sorry, but the service sports cards but it's currently unavailable in your country. And then micro cards will be available. All right. So now you've seen the country base and you've seen the path base, and that's because of the configuration that we've done. Now let's actually see how uh, our let's in quotes intercept the traffic and see the actual packets and the OSI, the datagrams that are going to be able to appreciate that your IP address is being sent along the data diagram. That's based on the OSI model. And as it's being sent, the regional internet registries are able to know your location because the internet service provider you've connected to has gone ahead and has allowed these IP allocations to be coordinated by the RIs. And due to that authority they have a database of all requests of all ISPs that have been given IP address set to work with. And that database has an API. So with that API from that database, you can actually query the API with just the IP address, and you will definitely know that this IP address belongs to this internet service provider and it's coming from this location. And with the authority of that, the internet service provider can now even narrow down to you that, hey, you are the one that is sending the traffic. So if anything, they know everything about you. That's why if you are someone who streams from adult sites, realize that uh, there's a message you mostly see on your browser that if you try to browse incognito, fine, you may be deceiving the end users that you are not visiting adult sites. But the truth is that you can't hide it from your internet service provider. You can't hide it. I remember I used to see that especially on Google Chrome. I know Chrome, Mozilla Firefox says, but it actually hide your browser from your screen content, giving you additional protection. Okay. But before you just hide it from your end user so they will not know. But it seems now things have changed. So I'm sure a lot of changes have taken place. Because this is what by default that it will delete all this and keeps it private. But if that's what has come along to, and that's very good because your internet service provider actually can do more. And it seems this browser too is providing more special features. So I think things are evolving, things are changing. So, but if you still doubt, you don't trust the browser to be actually keep you in private, you can change and move to a different browser, which is the best. Tor, the Tor browser with Tor, you are definitely guaranteed that nothing of that sort will happen. Like your internet service provider, the browser will not send any information to even your internet service provider because they're actually using the browser, which is the agent, to send traffic. This is your client, which I'll say, yeah, your client or your user agent, which you're using to initiate the request to the service. So, in one way or another, if you're the one causing it, definitely they'll smell traffic from you and then they can time, time, time sprint it to their database or log it to their database, and then they will definitely know that it's coming from you because you definitely registered with them with an ID card. It goes on and on and on. So that's how sensitive information is on the internet. But if you want to prevent all that, you can go with Tor browser. Tor will not send anything to them at all and keep you silent on the internet and because they are the ones promising you that. So Tor browser routes your traffic over the Tor network run by thousands of volunteers across the world. So you are guaranteed of secure internet. You are guaranteed. So let's just go ahead and start our, let's go ahead and